Good afternoon and welcome to the second workshop for the Picayune Watershed Water Quality Feasibility Study. This study was formerly known as the Collier County Subregional Water Quality Feasibility Study. The working group felt it important to change the name of the study to better reflect the area that comprises the study. My name is Joanna Weaver and I'm the project manager for South Florida Water Management District. On behalf of the district, I would like to thank the members of the working group and technical groups and the members of the public for attending the workshops and participating in this important study to develop alternatives for cost-effective water quality improvement to the flows to the outstanding Florida waters in Collier County. With the opening remarks for this workshop, I'd like to introduce Jennifer Reynolds, who's the Division Director of the Ecosystem Restoration and Capital Projects for South Florida Water Management District.
Good afternoon. First, I just want to thank everyone for participating today. We have about 100 people joining us on this call, and so we're so glad that you joined us. We're at a very important place in this study. We're at the point where we start to really roll up our sleeves and talk about what we can do now and in the very foreseeable future. We're all here as part of the team to ensure that our beloved and sensitive water bodies, including Rookery Bay, 10,000 Islands, and Collier Seminole State Park, get the cleanest water possible. We know that there have been long-standing ranches, agricultural businesses in this area, coupled with increasing development and everything associated with adding people to the landscape. All those activities contribute to the nutrients and the runoff that are problematic. This study is not about pinpointing the specific sources and volumes of these nutrients and flows. Right now, whether you agree with it or not, the upstream source contributors are in legal compliance with the statutes, the framework, and the regulations that are currently in place. And maybe you want to change some of those things. That's okay, and I encourage you to engage if you want to. But this is not the place to do that. This is the place to help us design some projects that fit onto the landscape that allow us to take the water that we have at the concentrations that we have and make it cleaner now. If in the future source control gets better, well, I don't think anyone will complain about our projects making the water too clean. I want us to be practical and pragmatic. So I want to get a few things out on the table up front. Farms in this area have been inspected by FDACs in the past 6 months. They are all in compliance with their best management practices. And Lippman Farms in particular is implementing advanced BMPs that exceed their regulatory requirements. They've also been a longtime supporter of the Picayune Strand Restoration Project and have in fact, which most of you probably don't know, made a significant contribution to the project by donating a necessary easement on their property for the project's construction. I want to focus on how we work together as a team with the water that we have. So let's not point fingers trying to place blame or making someone out to be a villain for continuing to run their businesses, water their lawns, or drain their streets or fields into the canals designed for those purposes. Instead, let's focus on what we could do if we can find a partner or partners willing to work with us. I would like to partner with landowners and/or developers to implement projects on private or existing public lands that improve water quality and don't create an additional burden on anyone. Maybe that includes enhancing treatment in existing stormwater ponds. Maybe that includes enhancing wetlands in conjunction with existing mitigation areas. Maybe that includes cleaning out exotic vegetation and creating a natural wetland, or adding chemical treatments to a settling pond. Maybe it's a project that would enhance the property for recreational use. Maybe it would be a temporary project allowing the land to revert back to existing use in the future, like our dispersed water management projects do. All of those are options that we can consider in this study. Let's focus on the map. Let's be realistic about how to make everyone a willing partner in the solution, and let's develop some projects I can have up and running in the next 2 to 3 years. I look forward to the discussion today, And again, thank you for participating with us.
Thank you, Jennifer. And now just to introduce some of our agency stakeholders who are working with us collaboratively on this study. And some housekeeping. For those of you joining us on your computer, if you're having any issues connecting to the Zoom platform, these are a few links that you can use. The first for technical support with some online resources that you can read through. And the second link here shows the live chat feature for Zoom to get any support that you need in connecting properly and hearing the audio during this meeting. Now, we will have a Q&A following the formal presentation, and at any point during the presentation, you can begin typing in questions to the question and answer box, which you'll see circled here in your dashboard for the Zoom platform. Again, here's another view of that. So once you click on that, it'll open a screen where you can type in questions. You can also see the questions that other participants are submitting. And if you agree with that question or want to give it greater importance, you can click on the thumbs up underneath that question so we know it's a priority for the audience participating today. Now, as panelists for this meeting, we have Kyle Goodwin from Stantec, Jennifer Brunty from Stantec, Amanda Ludlow from Stantec, and I will hand it off to Tim Hancock with Stantec as well.
Thank you, Yvonne. This is Kyle Goodwin. Yvonne, if you go back one slide, please.
Sure.
Well, we are excited to share with all of you on the call our progress on the Picayune Watershed Water Quality Feasibility Study. And we really are looking forward to hearing your feedback after the presentation. But I'd like to introduce myself and the Stantec team who's on the call today. My name is Kyle Goodwin, and I'm a senior project manager with Stantec in the Naples, Florida office. I'm the Stantec project manager for this project, and I'm working very closely with the district's project manager, Joanna Weaver, who opened up the presentation today. I have over 15 years of experience in civil engineering. I specialize in land development, project management, stormwater management. I'm a licensed professional engineer in Florida, Kentucky, and I hold an MBA. But prior to working for Stantec, I was a city engineer in Georgetown, Kentucky, where I planned city budgets, developed and executed capital improvement plans, and I managed the city's MS4 Phase 2 program. To my right on the screen, we have Dr. Jennifer Brunty, who has 27 years of experience in water quality, BMP research, and BMP implementation in both agricultural and urban settings. Her master's and doctoral level research focused on using BMPs to address nutrient management. And prior to working for Stantec, Jennifer worked as a natural resource specialist with Highlands County Lake Management Program for 5 years, and as a wetland scientist for the Southwest Florida Water Management District for 12 years. To the right of Jennifer, we have Amanda Ludlow. She's a principal in Stantec specializing in green infrastructure practices, sustainable treatment design, and she has more than 20 years of environmental consulting experience. She's spent her career focusing on the development of innovative, sustainable solutions to solve environmental problems, including constructed treatment wetlands, phytoremediation, natural media filtration, and sustainable stormwater management. And lastly, on the right, we have Tim Hancock, who's a principal with Stantec with more than 30 years of public policy and community outreach experience. As a Florida native, has extensive background working in the complex regulatory framework that is in Southwest Florida. And he also, for Stantec, leads public outreach and engagement efforts on environmental projects throughout the United States. So I'd also like to mention that we have several district and DEP staff on the call today who will help facilitate discussion during the Q&A session at the end of the presentation. And with that, I'll briefly review the agenda for today's meeting. Starting off today, we will provide a review of the first public meeting, and the review is going to include an overview of the project, recap of the purpose for the study, and a summary meeting review with a few key takeaways. Then we'll go into an overview of the information collection summary report, and the goal there is to familiarize you with it so you can go and review the full report if you're interested, and also walk through a few of the potential treatment technologies identified in the report. Following the summary report, we'll provide a brief overview of the feasibility study, We're going to review a real-world case study and walk through a potential solution intended to facilitate conversation and feedback from you all at the end of the meeting. And then at this point, I'll hand this off to Tim.
Thank you very much, Kyle, and good afternoon, everybody. I'd like to first provide a quick recap of our first public meeting that was held on this project on Monday, August 31st. For any of those that may be attending today that were not able to join us at that time. In looking at the last meeting, next slide will show us that the study overview and scope was provided in August and probably deserves repeating at this point. The focus of the study, as identified in part in the earlier comments from Jennifer Reynolds, is to review existing water quality improvement applications and studies and create an information collection summary report that will help inform decisions going forward. That report really is the primary subject of today's meeting. The next phase, as we'll discuss in more detail later, will be the feasibility study. The study area, which is depicted here, is generally shown and is intended to take the existing and future flows from the north and northeast and look for opportunities to apply proven water quality treatment applications to improve downstream water quality. And that downstream water quality is critical because it's being received by outstanding Florida waters to the south, specifically the Collier Seminole State Park, the Rookery Bay Estuarine Research Reserve, and Cape Romano 10,000 Islands Aquatic Preserve. Moving on to the purpose of the study, with the information collection summary report acting as a guide going forward, the next step is to develop a potential suite of cost-effective projects to improve downstream water quality via reductions in nutrient levels present for current and future discharges. As we discussed at our prior public meeting, this project is not intended to be a singular, comprehensive solution, but really should be viewed more as a piece of an overall matrix that will provide and improve conditions in a measurable fashion. As this exhibit shows, there are a number of upstream discharges and flows. They're restricted as they pass under US 41. Obviously, like a lot of Southwest Florida, we're dealing with a severely altered drainage scenario out there that is creating and contributing to some water quality issues. And again, this effort that we're focused on today is looking at opportunities for downstream water quality improvements and really does not have source control as its focus. The next slide will take us to today's meeting. With the information collection summary report being completed, we begin to look at how it informs us going forward, what comes next, and we'll delve into that a little bit later in this presentation as well. We'll also share with you once again the project schedule and the anticipated dates for the next public meeting. Now, at this stage, our key takeaways from the information collection summary report, as well as input received from the public and stakeholder groups from a high level, really are number one, that water quality is both a concern and a priority across Florida. I think the last few years have reminded us all how critical and key that is to the success of our state. The focus going forward in this effort will really be on passive systems that do not require a substantial degree of mechanical infrastructure to operate. And as mentioned previously, this effort is viewed as a part of a longer-term effort to address the ongoing issue of water quality in the area and looks to provide incremental positive impacts that can be part of a longer-term solution or solutions that serve to protect, preserve, and enhance the quality of the downstream OFWs. Now with that, I'm going to turn the presentation back over to Kyle Goodwin to review the information collection summary report. Kyle.
Thank you, Tim. So the information collection summary report is an important foundational aspect of the study and includes sections as identified in this slide. Yvonne, if you don't mind. The many stakeholders identified earlier in the presentation have been integral to the development of the report. They've been present throughout. They've been providing information, data sources, they've raised concerns, and have been guiding the study throughout the entire process. And they'll continue to do so throughout the feasibility study. Stantec reviewed a multitude of data sources and literature, both identified by the stakeholders and obtained separately. The data sources generally fell into three main categories. We had the water quality data, performance studies of existing water quality treatment systems, and descriptions of different technologies that might be used for water quality treatment. This information formed much of the basis for the summary report, and a table containing all of the data sources reviewed is included in this report. Also within the report, we discuss our methodology, describe how the data sources were reviewed and utilized. The literature review and analysis section is structured around applicable and non-applicable technologies and is essentially a consolidation of the information reviewed and presented in a format to support the feasibility study. Applicable technologies were defined as the most common or well-established stormwater treatment technologies already in use within South Florida. And they also include less common technologies that have a proven track record for nutrient removal within Florida. The non-applicable was defined as having uncertain effectiveness for large-scale projects or for use in the South Florida environment. Within the treatment options section, a table is presented identifying pros, cons, and a recommendation of whether or not to consider the technology for the feasibility study. In summary, the primary purpose of the information collection summary report is to inform the feasibility study. And in a few slides, Jen will review the full list of technologies identified in the summary report. Also included in the report, next slide please, are several maps and a site review memo. The area parcel map shown on this slide is presented in a much larger format in the report. It essentially identifies adjacent properties, and this map will be used in more detail during the feasibility study to bring scale to potential projects. The map is currently facilitating conversation, supporting efforts to identify potential project sites and to understand area limitations. And shortly, Tim will go into more detail about the feasibility study. But with support from the Florida DEP and Parks, site review was performed by Stantec staff to assess potential water quality treatment areas south of US 41, and a site review memo is also included in the report. Stantec has reviewed a variety of reports in addition to raw data files, and just to better understand water quality near the study area. Existing monitoring stations utilized by Florida Department of Environmental Protection, Collier County, South Florida Water Management District were identified, and water quality data from those stations was compiled and used as a basis for the water quality study. The nutrients summarized within the report include total phosphorus, total nitrogen, turbidity, copper, and iron. The monitoring station data for these nutrients have been mapped and overlaid on digital elevation models to help provide perspective. And as you can see, there's an example of the map on the right side. Additional information on the data sources reviewed, the review methodology, the summary table, and the full concentration maps are also provided in the report. So if you go and review the report, you can take a look at all this information. And then at this time, I'll hand it over to Jen, who's going to go through and review the full list of technologies that were identified in the report.
So the list of technologies on the right are the technologies that we're recommending for further review in the feasibility study. And the difference between these applicable technologies and the non-applicable technologies is that the applicable technologies on the left, as Kyle said, have a proven track record of working. A lot of them are very common type of technologies. We are looking at combining them, not just using any one technology, but combining multiple technologies into a treatment train, and I'll get into that in a few slides. But overall, spreader berms and canals, sedimentation basins, constructed treatment wetlands, polishing ponds, and various types of media filters are what we're going to be discussing further in this presentation. And additional technologies that are still considered for use in the feasibility study would be restored wetlands, air diffusion systems, and periphyton. We're not going to talk a lot about those here. Restored wetlands is fairly obvious. Air diffusion systems is basically throwing an air diffuser or fountain or something into a pond or open water area, and that can have some effectiveness on removal of nitrogen. It's kind of a supplemental technology that may or may not be added to any kind of treatment train. Periphyton kind of goes along with constructed treatment wetlands. It's different organisms that are growing on rocks or other plants, and would probably naturally appear in constructed treatment wetlands anyway. Non-applicable technologies, the hybrid wetland treatment technology, we did consider this after the initial report. We had a number of people asking us to consider this. We've left it as non-applicable because part of this treatment technology involves the use of alum, and there was a lot of sentiment against using alum treatment in natural systems. Nutrigon media is not really a proven technology. Recycled water, it's kind of marginal. It was identified as something for further research in the C43 basin. Recycled water containment areas, this is berming up agricultural lands and holding water on them to let nutrients settle out and possibly be used for crop uptake later when the area is no longer bermed up. This is sometimes called water farming. Algal scrubbers just aren't that effective on a large scale. Alum treatment, as I said, just has a negative association with it, especially with incorporating it into natural systems. Flooding treatment wetlands only have really a small scale effect on nutrient removal. They're basically floating wetlands that are built into a mesh that floats around on top of open water, and their nutrient uptake ability is limited. Downstream defender, again, is a technology that's not really, it doesn't have a long track record. Aquifer storage and recovery and deep well injection really just don't apply. They are included in the information collection summary report because we were given a number of documents to review that did mention these, but we're not suggesting at all that those be used. Next slide. So the spreader, canal, or berm, the purpose of this is, as you can see on the right, water flows in at a point source inlet and spreads out over an area, either behind a berm or in a created canal. And as it does this, a lot of the sediments will fall out, and a lot of the nutrients in water is actually attached to sediments. So as the sediments fall out and settle out to the bottom of the swale or the area behind the berm, a lot of the nutrients are initially removed that way. The water can leave a spreader swale or spreader berm area by either, there could be a berm or the edge of the swale at a uniform elevation across a length of land, so that as the water rises, it spills over uniformly. There may be a berm that has a number of culverts through it that also causes the water to spread out in a dispersed fashion, mimicking sheet flow, which is always desirable compared to having just a single point source where water is blasting out into just one little area of land. And by spreading the water out, you first slow the velocity, letting sediment settle, and it also reduces scouring in the receiving area. Some limitations to this is you have to have an appropriate downstream receiving area. So you don't want the water overflowing the edge of the canal or the berm into a sensitive upland area that's going to be adversely impacted by suddenly receiving a whole bunch of water that it didn't receive before. Or say there may be gopher tortoises downstream of the spreader berm and they would get drowned out. So you have to have the right kind of receiving land. You also have to have a length of linear land in which to build these things, which may or may not be possible depending on site specifics. It also requires periodic maintenance and through the removal of sediment from the bottom of the canal or behind the berm. If a big storm kicks up and a lot of sediment has accumulated, it's possible that the sediment can be resuspended and discharged, and along with it, nutrients attached to that sediment would be discharged. So these do need to be periodically maintained. Next slide. Sedimentation basin has some similar functions to the spreader Burma Canal. Basically, it's a pond where water flows into it and has a chance to slow down, and sediments have a chance to drop out of the water column and settle on the bottom of the pond. This is going to be mostly larger particles, but some smaller particles can settle out as well. This is a really simple thing to design, and it can be sized really large or really small, and is easily incorporated into treatment drains. It has excellent sediment removal capacity, and as a result, it's excellent at removing constituents attached to the sediments, such as the nutrients. Just like the spreader canal, it requires periodic maintenance to remove the sediments that have settled out, so that if a big storm event comes, they don't get resuspended and discharged, just like I said with the previous slide. These, because they can be many different sizes, if they may require a large land area, and that just really depends on the amount of water that you're trying to treat and the amount of sediments in the water that you're trying to treat. Next slide. And finally, the constructed treatment wetland. This is basically a wetland that got built in an upland, and the whole idea is to mimic the physical, chemical, and biological treatment mechanisms that occur in natural wetlands, which is, first of all, water slows down and sediments settle out. You can design these in a number of ways to cause a number of different types of treatment. One of the key factors is, though, these constructed wetlands will have a lot of plants growing in them, and plants are excellent at uptaking nutrients and removing them from the water column. They slow down the velocity, like I said, and let sediment settle out. The shallow marshes filter out the finer sediments, which doesn't necessarily happen in just a deep open water pool. The dissolved nutrients are taken up by plants, and they can also absorb onto marsh sediments because the water is moving so slow generally. An additional benefit to constructed treatment wetlands is that wildlife tend to really love to congregate in these, and a lot of wading birds do a lot of foraging in these, just like they would in a regular wetland. Typically, constructed treatment wetlands have low operation and maintenance costs if you can get them set up right and keep nuisance and exotic species out. Some limitations is that the treatment rates of a constructed treatment wetland are very site specific. Depends on soils, it depends on the nutrient concentrations in inflow waters, depends on how much time the water spends in the wetland, and a lot of other things. And also a disadvantage is that to get the full amount of treatment that you're looking for, you may need a very large land area to meet water quality criteria. Although if you don't have that large land area, constructing a treatment wetland can remove at least some of the nutrients entering it. It can do a pretty good job even if it's not large enough to fully treat the water. And next slide, and Amanda will be taking over.
Thanks, Jennifer. So this example is of a polishing pond. So polishing ponds are essentially a series of smaller sedimentation basins, similar to what Jennifer had explained earlier in a previous slide. They're primarily used for sedimentation practices, so removing solids and the nutrients that are associated with those suspended solids. They are very well fitted into a situation where a larger sedimentation pond wouldn't be practical due to land area limitations, so they can be more strategically fitted into a specific site design. So initially, that first sedimentation basin pond is used primarily for large suspended solids removal. The second pond and the third ponds and any additional ponds beyond that are primarily used for reducing resuspension of sedimentation from previous ponds, as well as re-aeration of the water prior to discharge. So similar to the previous practices, there is going to be some periodic maintenance through sediment removal, excavation and removal of those settled solids, which could limit the use of this technology. Next slide. And this last example is of a media filter. So media filters utilize physical, chemical, biological reactions to remove the specific contaminants through filtration, adsorption onto the media surface, chemical transformation, degradation, and ultimately sequestration in the media matrix. They're designed specifically for specific nutrient removal by selecting a specific media. For instance, organic media such as compost, peat, wood chips for nitrogen removal, or in this schematic, using iron-enhanced sands for phosphorus removal. Now, because they are filters, they can clog easily. So it's extremely important to have an upfront solids removal step as a pretreatment, typically in the form of a sedimentation pond, as shown in this schematic, where solids will settle out and not clog the filter as it functions in a downflow filter. Because of the potential clogging associated with the media filters, and as well as the contaminant-specific design, media filters can be added to the end of a treatment sequence to polish effluent prior to discharge, thereby concentrating that treatment for a specific contaminant of concern. Next slide. And I think we go back to Tim.
And thank you very much. This is where we kind of bridge the gap. What you've just heard is basically a summary and hopefully some graphic elements that help you visualize what are sometimes rather difficult concepts to take from verbiage or reports and actually see how they can be used or how they can apply. And we will be discussing a little bit and going over a couple of case studies in a few moments. But at this point, this is where we transition. If you will, take a look at when you go back and look at the 4 or 5 things that have been described here today, we consider those the tools in the toolbox. After all of the data and summary review that has been performed on the technical side, we've ruled some things in as potential. We've ruled some things out as potential. Now what we need to do is begin looking at, okay, if we have these tools available to us, these are the ones that seem to be most readily available to have some positive impacts in that 2 to 3 year window that has been described. Okay, now how do we make those work? So as we look at our next slide and we talk a little bit about transitioning into the feasibility study overview, what is the feasibility study going to do? So again, everything you've seen up to this point is really that informational side. We've kind of built the tools to help us go forward. So at this point, we've identified some of the problems. We certainly have looked at a lot of the constraints. One of the things, and there's a question in the chat box, and I think we might as well tackle it at this point, because one of the issues is almost any solution we look at in providing downstream water quality treatments take land and space to accomplish. Now, not all land is created equal. So part of the feasibility study is looking at these potential applications, determining where and if there is land and site available to achieve some of these things. And obviously you want to select that land carefully. You want to minimize impacts to larger systems and so forth. So that's all a part of the feasibility study. This is where we take the puzzle pieces and we begin trying to insert them into the landscape in a manner that is appropriate and effective. And then we will use that to formulate the different alternatives. We will then evaluate the alternatives, make a comparison among them. And also, we don't operate in a total vacuum here. There has to be a funding focus as to what recommendations we make going forward. It will do no one in the community and no one in this call any good for us to propose solutions and ideas that have no funding viability. So we want to make sure we operate with those constraints in mind as well. And then, of course, at our next public meeting, we will be discussing the recommendations that come out of the feasibility study. So once again, where we are right now, information data collection and assessment. We have some tools in the toolbox. Now we want to see how we can apply those in the actual physical landscape going forward. And what I'd like to do is I'd like to ask Amanda to come back on and share with you some of the case studies, just to look at some of the concepts we've discussed in a little more of an abstract and put them into place as to how they're being used in projects, maybe not of similar scope, but they can be scaled appropriately. So Amanda, would you like to take over?
Sure. So the case study that we selected, what we thought was a really good example of a natural sequence, treatment sequence that has been implemented and is functioning very well for nutrient removal. So Freedom Park is in Naples, and it is an example of a specific sequence that uses natural treatment processes for a watershed-based solution to a water quality problem. Freedom Park is about 20-acre treatment system. It's constructed to manage runoff from about 3,000 acres. If we go to the next slide, we can have some summary bullets. 3,000-acre watershed, which consists of runoff from residential, industrial, commercial, and recreational land, all prior to discharging into the Gordon River. So the 20-acre treatment system is composed of a 4.7-acre sedimentation pond, similar to Jennifer's description of the primary purpose of that pond is to promote sedimentation and removal of suspended solids and the nutrients and contaminants that are associated with those solids. Then water flows into a series of 3 treatment wetlands. And these treatment wetlands are a mixture of shallow marshes and deep open water ponds. And that the function of the treatment wetlands is to remove those residual solids, filter out those solids, absorb, sequester the nutrients prior to discharge into a 11.4 acre restored natural wetland. So overall, like the whole system treats about 200 million gallons of water a year before the Gordon River discharges into Naples Bay. They've seen significant nutrient removal, total nitrogen being reduced by 41%, whereas total phosphorus has been reduced by 84%. And then as consistent with the sedimentation practices, they're also seeing metals reduced to background levels prior to discharge. So one of the unique aspects of this project as well is that there are a number of pedestrian boardwalks and nature trails. So if any of the attendees are interested in seeing a natural treatment sequence in person, I would strongly suggest going out there and taking a look at this project. Next slide. I think I pass this off to Jennifer now.
Yes, thank you. So we've just gone over a case study that described a number of different technologies being used in a treatment train. And what our feasibility study is focusing on is taking the 8 different technologies that we have identified as applicable to this project for further review in the feasibility study, 5 of which we've described in detail here, and proposing them in treatment trains with using the technologies in different orders. So this particular slide only shows one order of using the technologies. There could be 100 different combinations of putting these together. So this is just one example. So this is not the only thing we're proposing. This is just to give you an example of the types of things we're doing. We could be putting the wetland earlier and the sedimentation pond later. Not necessarily, but we'll be looking at what's most logical and what we can fit into the space that we have available once we know what the space that we have available is. So in this particular example, we have water coming in to a spreader swale, perhaps entering from a canal or from one of the culverts that go under 41. The water may discharge over that spreader swale into a natural area, and after which it may move on to a sedimentation basin. And this depends, there's a lot of different design considerations that need to be considered on how the water gets from one technology to the next. But so the initial treatment of the water in the spreader swale would be some sediments settling out and then a dispersed flow, and the water then moving on to a sedimentation basin where additional sediments settle out along with the nutrients attached to the sediments. And from there, the reduced nutrient water would move on into a treatment wetland, which would remove the dissolved contaminants through plant uptake of nutrients dissolved in the water, and it would remove fine sediments as the water further slows down and goes through plants that can trap those fine sediments. From there, the water can move into a media filter, and the media filter is typically going to be placed at the end of the treatment train or later on in the treatment train after the sediments have been addressed, because media filters can clog easily if they are inundated with water with a lot of sediments still in them. So after the water has been treated in a media filter, it can discharge either through a spreader swale or a spreader berm where it overflows into a natural wetland receiving system, or it may discharge directly back into a canal, depending on where all of the technologies are located specifically and the site-specific limitations or requirements or opportunities associated with where we end up being able to put our treatment train. Next slide. I believe this is Kyle.
Actually, it's Tim, but that's all
Tim.
right. If Kyle wants to jump in, I'll be happy to give it to him. But yeah, I want to thank Jennifer, Amanda, Kyle, and others for kind of going through this kind of a large scale, more graphic focused overview of what processes are being further considered as we move into the feasibility stage, as well as, and you saw in that diagram, you saw 4 or 5 different ways in which water can be treated, how they could be used in a train. Maybe you accomplish 2 of the 5, 1 of the 5, 3 of the 5. But the good news is that they are all scalable. And I think that's going to be very, very important as we look at the available opportunities from a land-based standpoint to implement these, to have as many tools in the toolbox as possible and be able to put them together in the most effective way that we can. So what we're looking at as we go forward is we're looking at, we've kind of gone through and given a project overview here on the collection summary report. And Yvonne, if you can move to the next slide, please. What we're going to do going forward here again, before we get to the Q&A, is, with the information summary report now complete, we're obviously taking input today, and we'll use the information collected to date to help us move into the feasibility study. We'll be working with a stakeholder group, and I do want to personally reach out and say thank you to all the folks in the stakeholder group that have given us a significant amount of their time and input as this process has unfolded and will continue to track. Want to thank them all, but we will continue working with them and reporting back to them on identifying the most appropriate application of the identified processes that we've outlined for you today. And again, we're looking to provide the greatest benefit given the project and physical constraints. Our next public meeting will be the week of December 7th, and we look forward to, at that time, reviewing the project status and any recommendations with you that we may have. Before we go into the Q&A, I'd like to turn things back over to Yvonne to assist participants once again with how best to pose any questions to our panelists or district staff, and we'll certainly do our best to provide as much information as we can at this stage. We can't promise that we're going to have answers to every question, but hopefully we can at least provide additional information and give some guidance where possible. Yvonne?
Thank you. And again, if you have any questions that you have not yet had an opportunity to submit, please go ahead and click the Q&A button at the bottom of your dashboard. Here's a close-up view. And if there is a question, and I see some of you have already done this, if there is a question that you agree with and you would like priority for it to be answered, please make sure to click on the thumbs up and we will know it's a priority question. So thank you very much. And we will go ahead and get started with the questions. So we did receive a question from Mr. Rasmussen. Why focus on cleanup methods as opposed to eliminating nutrients entering the environment?
And this is Tim Hancock again with Stantec. David, you know, if I think if everyone on this call could take out their magic nutrient wand and wave it across the landscape and make projects like this no longer necessary, we would all do it. One of the problems is we have decades of development and operation and input occurring out there. And so we need to be looking for more than just one solution. So while we work in the slower, if you will, framework of dealing with changes in use, education of homeowners and property owners and what to do and what not to do, as well as working with regulatory bodies to slowly over time bring into place regulatory changes that improve water quality. We need to be looking at opportunities such as the one before us. And I think in the case study, Freedom Park was a really good example. You know, those of us that have got decades of experience living in Southwest Florida know that, you know, Naples Bay went through a very significant period of extreme degradation, and we knew where the inputs were coming from. And Freedom Park was one of those kind of interceptor concepts that said, look, it's going to take us a long time to change the behaviors, to maybe change the regulations. So why don't we go ahead and intercept and treat what we can and make the improvements we can? And that is a bit of a success story that I think we look to. So I think we have to look at this as a multi-pronged approach, not just dealing with the inputs, but also dealing with the fact that anything we can do along the treatment stream to improve downstream water quality, we should take advantage of those opportunities when we can. So just think of it as one part of an overall strategy that isn't just focusing strictly on the nutrient source alone. So you also ask a couple of questions, and David, I'm going to handle both of these because they're very similar. You ask about the opinion on using reuse water for land adjacent to impaired waterways, as well as landscaping and lawn fertilizer on land adjacent to impaired waterways by the DEP. You know, again, these are both questions where I think we can all agree less is more. The less material and nutrients that go into the downstream collectors, the better. But again, this study is focused on looking at tools that we can apply on the ground to help improve downstream water quality. A lot of what you're asking about here really is going to take cooperation and collaboration from regulatory bodies, from local, county, and state government to make those longer term changes and to affect the way in which we operate. I know Collier County Pollution Control has got a significant education program. They're out in the communities with HOAs all the time, working with them to try and improve upon application standards and educating residents and homeowners and when to apply, how to apply. We've seen the city of Naples really kind of take an aggressive position with when and how you can fertilize. So again, I think as these things change, we continue to want to support those, but we need to be looking at all aspects. And I think midstream and downstream projects that can improve water quality will help solve that. So hopefully that answered your question. Yvonne?
Thank you, Tim. So our next question, we're getting some questions moving up in our priority. So one question that we received from Mr. Rumbold, a question above alluded to agriculture as a source. He may have missed it, but what are the sources of these nutrients? Is it mainly agriculture or the Golden Gate area? Are we considering future loads from developments in East Collier, such as the proposed Rivergrass Village and others? Mainly, he would like to know what the primary nutrient source is, phosphorus, nitrogen, well, primary nutrient, phosphorus and nitrogen that you would like to reduce. And he mentioned each is removed differently, particularly if it's organic nitrogen.
Thank you, Yvonne. Jennifer Brunty or someone from the district, would you like to take this question?
I can answer this question. I'm not going to get a lot into the nutrient sources since we're not focusing on the sources in this study. It comes from a variety of different areas, including agriculture and the developments that are in the watershed. The primary nutrients of interest are both nitrogen and phosphorus. Each is definitely removed differently. There are some technologies that remove one but not the other. The technologies we talked about above are typically going to remove both. Sedimentation basins and wetlands with plants uptaking both nitrogen and phosphorus to grow will remove both. Organic nitrogen, I think much of the nitrogen that's entering the system is not actually organic nitrogen. I believe it's inorganic. We have a section, Appendix B, in the Information Collection Summary Report that talks a lot more about the nutrients that are coming into the system. And there's maps showing where the nutrients are higher and lower. So if you're interested in that, I would suggest reviewing Appendix B of the Information Collection Summary Report. So we are considering, though, if we do implement a technology that focuses on removing phosphorus, we would have a corresponding technology, if possible, to focus on removing nitrogen, and we would also focus on the technologies that remove both.
And Jennifer, I think the final aspect of this question was if the technologies that we're considering, when we're thinking of those, if we're also considering future loads from future developments and future growth in the area that may further impact the water.
Yeah, what we're considering right now are existing loads. Future loads in the sense that the Picayune Strand Restoration Project is expected to increase the quantity of flow discharging south of 41, which when you increase quantity, you're increasing total loading. So we're addressing the future flow of the Picayune Strand Restoration Project, but not future loading from any other land use.
Now, another question that we've received is if we're in our process, if we're considering water quantity as well as quality, i.e. storage.
So yeah, I can take that. So this also overlaps into a couple other questions with respect to the estimated daily, yearly flow to a proposed treatment system. So maybe this would be a good time, Kyle, if we put up a map that shows like where BR36 is located, and we can use that as an example. So I think it's the next slide.
Is it slide 31? This one down
Use
here?
32.
32.
Okay, thank you.
So yeah, this addresses a number of questions too with respect to the scale, and technically how many freedom parks would we need to capture and detain and treat these constituents. So at BR36, the average daily flow at that location is about 72 million gallons a day. So significantly higher than a freedom park. So yes, you would need dozens of freedom parks. So due to potential space restrictions, where there's going to be a balancing act between how much of that flow can you treat within a specific land area. So if we tried to treat the entire flow, you're looking at 500 to 1,000 acres to treat the entire flow. So that is not likely feasible. So we'd have to be looking at capturing a specific percentage of that flow and diverting it to a treatment system based upon what land is available to construct the treatment practice.
Thank you. And another question that we received is really asking, what is the problem that we're trying to address with this study. They're asking us to really define that problem for them.
Thank you, Yvonne. I don't know, Tim, is this something you'd like to cover, or maybe Jennifer Leeds or Jennifer Reynolds?
Yeah, I think the problem is multi-pronged, but I think Jennifer Reynolds, this may be most appropriately coming from the district, since the scope was developed by the district and the Big Cypress Basin going forward. So, as far as what this particular study is trying to accomplish, or what specific problem it's intending to address, would you like to kind of provide a little summary on that?
Yeah, I can start, and then I can't remember, do we have one of those flow slides? Is that in the slide deck? That shows how water flows off of the Picayune Strand project?
Yvonne, you need to go back
remember.
about 10 slides. Keep going up. It'll be slide 10.
Yeah.
Thank you.
And Jennifer Leeds or Joanna, I'm gonna pitch it over to you in just a second. So there's also a couple of other questions that, while I have the microphone, I'll touch on as well, because I really appreciate all of the comments and the questions today. Part of the reason that we wanted to make this a very public process was to encourage and incorporate feedback from the public, from landowners, from local agencies, and from state coordinating agencies. That's part of why it was really important to us to do this as a very public process, because there is limited land available in order to look at treatment opportunities in this area, as we look at the flows increasing as a result of the Picayune Strand project. And so a couple of things that we're doing concurrent with this study effort are efforts with some of those other agencies. So we are looking at land ownership within the study area and coordinating with the agencies who own and or manage the land in order to address any potential for better source control or better management practices on those properties. So we're doing that concurrent with this study effort, and we'll be able to give you updates on that as we progress. But we don't want to wait and count on those things being able to solve the problem, because we know that the problem is bigger than that. And so we are doing that. We are also looking for opportunities for landowners that are in this area to do some of that themselves. Take a look at opportunities within the management of their own lands, whether those are HOAs, private businesses, different folks who manage their lands, and seeing if there are opportunities for them to be part of the solution. Are there opportunities for them to hold back water on their own lands, to use reuse water for irrigation, things like that, that there are grants available, not necessarily as part of this study, but concurrent with this study, that we are willing to assist folks with if they need technical help in order to figure out how do I get started to do something like that. We want to encourage those conversations as part of this endeavor. And then to take a look at what the actual problem is that we're trying to solve, I'm going to pitch it over to either Joanna or Jen Leeds, if you could kind of explain how this fits together with the Picayune Strand project. I'm not sure if this is the best map for you or if you wanted to use a different one.
This is Jennifer Leeds, so I'll take the next stab at it. Really where this kind of, to bring it all the way back to the beginning, especially for some of the folks who were not able to join us for the first public meeting, is it kind of came about when we were getting close to finishing off trying to award the last contracts for the Picayune Strand Restoration Project. And there's some additional culverts that are going to go under US 41 and County Road 92. to help facilitate some of the sheet flow that we are going to realize as a part of that restoration project, right? With some of the canals that we're backfilling, the roads that we're taking out, the current flow methods for water to get under US 41 and then down into Collier Seminole State Park and those other areas, instead of being funneled into Picayune Canal, they're now going to be spread out. And so a lot of questions came up with those new project efforts that were going in, and then also with the levee that's being built. We call it a Southwest Protection Feature that's on the west side of Picayune Strand and to the east side of the ag and the urban areas. And that is there to provide flood protection, but it's also going to help funnel some of those flows that are coming off from the ag and urban areas and Bellmead up to the north and bring them south. And so a lot of the local stakeholders, folks like you on the line, were asking a lot of questions about the quality of the water, the quantity, where it's going into the downstream areas. And so because water quality wasn't a focus of the SERP project, the Water Management District said, well, you know, these are really important questions. They're really important issues. Water quality is at the top of the state's priority. It's one of the governor's priority efforts when he took office. And so he said, what we want to do is exactly like Jennifer Reynolds laid out, is we wanted to do this type of a feasibility study to reach out and work with not only the other agencies that are in the area, but with local stakeholders and with knowledge to see how we could come up with solutions that would address some of these issues. And it's not easy. We're, like everyone has kind of said, we're doing a balancing act. There's a lot of outstanding Florida waters. There's a lot of conservation. There's state parks. There's preserves down to the south. And so it's this kind of balancing act of how can we either reroute flows, how can we put in alternatives or projects that can help improve some of the water quality, and how can we partner with people, and at the same time, how can we look for like cost sharing projects that are out there to help fund it as well. And also at the end of the day, we heard from a lot of the local stakeholders that they really wanted to be able to communicate this to their state legislators, because to get a project off the ground and moving, you need funding. And how do you do that? You need to be able to communicate what the problem is and what the needs are and what the cost will be to the people who will fund these types of things. So that's also one of the products that's coming out of this study. So at the end of the day, we'll end up with several different alternatives. It could be one project, it could be 2 or 3 put together. It could be partnering with private landowners, it could be partnering with other agencies, it could be looking at multiple funding sources for other projects, kind of in a culmination of how do we kind of really get at what could really be best for this area. So I know it was a little bit long-winded, but I thought it would be good for the folks to hear who weren't, like I said, weren't able to join us during the first call, to kind of get that overarching, this was really the thought process that went into it, and also kind of where we're at today. So that's kind of like defining the problem. It was really more of a culmination of several things.
Thank you, Jennifer. And so some questions may reiterate questions that were previously submitted by other stakeholders, but we'll go ahead and run through all of them just to see if there's anything that our panelists would like to add. So one question that has come in is, will only one treatment train be used, or will several different treatment train paths be utilized and compared for the best method?
And I think the answer to that, this is Tim, is going to be that will be determined in the feasibility study phase. At this point, again, we've identified the tools and possible applications, but we'll tackle that more in the feasibility study.
Thank you, Tim. Another question that we received from Mr. Tyler, waters that currently flow south from the farms immediately north of US 41 and currently monitored by Collier Pollution Control at the Tomato Road monitoring station are a point of concern. Currently, those waters flow east along a canal and presumably flow under US 41 at the east end of the Collier-Seminole Park. How much further monitoring currently occurs regarding the outflow of the agricultural pollutants contained in those waters?
Thank you, Yvonne. We don't have anyone from Collier County here on the panelist list, so to answer that question in specific detail will be a little bit of a challenge, but it's my understanding that the monitoring stations are currently operating. I don't know if that answers your question or if anybody else on the panelist list would be able to expand on that.
Well, and Kyle, I would assume with the additional, openings that are going to occur as a part of the Picayune project, there will be additional monitoring that goes with that down the road. But again, if I'm incorrect about that, the district can correct me, but that would follow the logic.
This is Joanna Weaver. There are some water quality monitoring stations further east along 41, in addition to the one at Tomato Road. And if, we decide that additional monitoring is required to gain a better understanding of nutrients in the flows, that certainly could be a recommendation of the study.
Thank you. Now, one question that a few stakeholders have submitted is if there are any specific sites that we are considering with more priority over any other sites.
And again, this is Tim. I'll tackle that one because we don't want to get ahead of ourselves here. We want to address that in the feasibility study. Obviously, conversations will need to happen with property owners. And again, it's a little bit of a jigsaw puzzle of trying to put the pieces together as best you can to have the greatest result and the largest improvements in downstream water quality. So can't answer that at this stage, but I look forward to that week of December being able to add to that and give a little more information in that area.
Thank you, Tim. And another follow-up question from Mr. Tyler. If we can't focus on the sources, then how can you devise appropriate systems to efficiently mitigate? And I believe Jennifer Leeds touched on this question, but I'll go ahead and ask it again just in case anyone else has anything else they'd like to add.
I guess this is Jennifer Reynolds. I'll just jump in because I don't want it to sound like we're not answering a question. So we are certainly looking at what the contributing waters are in terms of what are the nutrients in there and what are the volumes that need to be treated. And so that's how we're looking at the scope of the problem, not necessarily trying to pinpoint how much of which of those nutrients are coming from which specific property, for example. But rather, as we look at the picture that's on the screen right now, as we look at this water that used to flow through the Picayune Canal and discharge directly into 10,000 Islands, it's the same water, but now it's being distributed differently. And we want to make sure that we don't have any additional impacts to other areas as we are addressing the source controls through other concurrent activities.
Thank you. Another question that we have received and I'm trying to make sure that I'm reading this properly. They have appreciated the explanations that we've given thus far, but I guess they wanted a little bit of clarification. If the water quality is poor, why not go through the impaired waters rule, TMDL, and best management practices?
This is Jennifer Leeds. I'll take that one. So it's a good question, and certainly we can do that. You could do that in a parallel effort. It's a little bit outside of the scope of this particular project. This was more focusing on something that could be done very quickly. TMDLs and BMPs, they take a long time, especially if you have to go through rulemaking. Those could be years away. I don't think anyone wants to wait for that, but certainly that can be an effort that can be pursued by people outside of this particular project, while at the same time, we tried to look at what we can do in the near term to help improve some of the water quality flowing into the downstream areas.
Thank you. Now, what responsibility do the farmers have in covering costs to clean up their runoff? And I know at the beginning, we did mention that FDACS has been working with farmers and they are meeting the requirements and guidelines. But just in case, we'd like to elaborate a little bit more.
I think Jennifer did a nice job at the introduction of talking about how those landowners are working in a collaborative fashion with the district going forward. And some are even exceeding their expectations out there or what their standards are. And I think that kind of continued collaboration is important. We cannot underestimate or understate the importance of agriculture to the area, to the economy, to our food sources. So it's part of the balancing act. And again, we are looking for continued collaboration. We're looking for landowners that are willing to enter into pilot projects, anything that we can do to kind of push that innovative edge forward. And I think we see a willing participation from landowners, but again, these are businesses and they do, as long as they're operating within their permits, then there's a limit onto what can be, exacted at that point. So again, I'll ask the district to add any follow-up if they wish, but I thought it was covered fairly well at the beginning of this.
This is Jennifer Brunty, not with the district, but I've done a lot of work with ag over the years, and I've worked with FDACS and their BMP program. And if a farmer is enrolled in the FDACS BMP program, which this farmer is, and they're keeping the records properly and doing everything that they agreed to do in that BMP program, they do get a presumption of compliance for state water quality standards from the state. So the state cannot hold them responsible for paying for cleanup as long as they are following their FDACS BMP program.
Thank you. Another question that's come in, county hydrology is under stress from both agriculture and residential development that seems to be getting worse. 77% of the land in Collier County is preserved, according to county reports. What action can Ms. Reynolds take to focus these public lands on water quality and habitat corridors?
Sure, I can take that one. What I can commit to is looking at the land ownership across Collier County, and we are doing that in conjunction with the agencies that own and manage those lands in order to look for potential for doing better source control and doing anything to improve management practices on those lands.
Thank you. Another question we received, how do we see alligators, alligator holes, and various hammocks spreading out throughout large areas as a treatment option?
This is Jennifer Brunty. I'll go ahead and answer that. We're not planning to use natural wildlife habitat areas for treatment. That could be counterproductive to the promotion of wildlife habitat. So what we're looking at is constructing treatment in uplands, possibly severely degraded wetlands, but not in high quality current existing animal habitat. That would not be a desirable thing to do.
Thank you. Now, what is the daily yearly flow being considered for treatment?
So I believe we actually addressed this in a previous comment with respect to, for example, at BR 36 being the average daily flow at that location was 72 million gallons per day. So I think we lumped that response into a previous question. So we would be limited to the amount of water we could treat based upon available land for a treatment system. So it would be not necessarily driven by the total flow at that location, but more what we can actually feasibly treat within a specific land area.
And I think, Amanda, you did a nice job with this a little bit earlier, but I think there's several questions that followed afterwards that kind of lead into the same thing about, look, you know, to treat the whole area, you would need dozens of freedom parks, or this is not enough, or this is, you know, that type of thing. But the reality here is that what we're looking at an incremental step here. It's one thing, it's not a silver bullet, it's not the be all end all. But if we can treat and improve water quality for a portion of that 72 million gallons per day, we're doing more than we are today. So I think we're being asked to look at this certainly from a big picture standpoint of having one incremental impact that can improve downstream water quality. And if that's a fraction of that 72 million gallons, then at least that is something that's being treated that's not occurring today. And I think that's an important tenet of what we're looking at.
Thank you, Tim. Now, another question that we received from Mr. Roth, he has a concern that these are online best management practices for a massive drainage area, which he feels isn't practical. Is there maybe some response we can provide to alleviate that concern?
Well, I think it goes back to what we were just saying, which is that, you know, again, if you're looking to treat the whole system with one project, that's just simply not going to happen. The available land is not there. But again, we're looking at incremental steps. And I think you have to take an approach of, you know, if you can't do it all, then do nothing is really not a viable alternative. I think we do want to take the lead of the governor and the governing board and look at opportunities to make improvements where possible and to do that in a fiscally responsible way. So that's the approach and kind of the marching orders that we've been given, and hopefully we'll be able to help the community succeed in that way.
Thank you. Another question we received is if the lakes are brackish or freshwater in the developments. This isn't really related to our study, so I'm not sure that we can answer it, but I will raise the question since it was brought up.
And I'm sorry, Yvonne, was this the question about brackish or freshwater?
Yes.
Okay. And again, I'll give you the non-technical response and then let somebody correct me if necessary. But as someone who was born and raised in Florida, you know, it really depends on the hydrology and the hydraulic connections. You know, I can remember, you know, being in areas where you felt like you were way inland, and next thing you know, you're fishing and you jump a tarpon, which is a saltwater species. So obviously there's been some type of hydraulic connection there. So the closer you are to the coast, the coastal areas, the more likely you are to get some of that kind of that saltwater push. But a lot of the projects, the SERP project and others, are kind of restoring historic hydro periods to the degree we can to kind of push back against that saltwater intrusion and that conversion, if you will, of what could have been or maybe should have been a freshwater system into a brackish system. So I don't think we can give you an answer from a holistic standpoint. It really is case by case, location by location, and it all depends on the hydraulic connections for that body of water. But you know, don't be surprised. I've fished in plenty of places in Collier County where on the same lure, on one cast it's a largemouth bass, which is a freshwater species, and on the next cast I'm getting hit with a tarpon. So I think the idea here is to try and get that natural balance as best we can. This project isn't focusing specifically on that, but at least that's some anecdotal background from a Florida boy.
Thank you, Tim. And now Tracy Robb, one of our attendees, isn't able to type in his question or his or her question. So we're going to unmute Tracy. If you would like to introduce yourself, say your name for the record, and ask your question. Tracy, you've been unmuted.
Yes, sorry,
you.
I didn't mean to hit the button.
Oh, okay.
Sorry.
No, thank you. We just wanted to make sure everyone had an opportunity. For our next question, Mr. McAvar thanked us for the summary of potential solutions. Is there an equivalent summary of the problem, specifically where the water we are trying to address comes from? What is the quality of the water? What is the design volume to be treated? Again, I believe this question's been answered, but since it was asked, I wanted to make sure to raise it.
This is Jennifer Leeds, so I'll kind of follow up a little bit to Tom's question. So we're primarily looking at, what we kind of want to call the Picayune watershed. So we're really looking at, waters from the Picayune Strand SERP project. We're looking at flows from Belle Meade, the ag area and the urban areas, all to the north of US 41. And all those flows as they head south under US 41 and into Collier Seminole State Park and the further areas into the downstream areas. And so, Tom, within that, we do have, information, flows, stage, and some water quality information in all of those flows. We're not necessarily at this point looking to use that to put into like a design for like a stormwater treatment area. We're trying to see if we can focus on something, some type of solutions that'll be kind of on a smaller scale, maybe more passive in nature. But looking at, what is the quality of that water and which of those alternatives would be needed to address those issues and concerns. So I hope that helped out.
Thank you, Jennifer. One of the stakeholders has asked if they can receive a copy of the slides presented here today. One thing I can say is that this is being streamed and a copy of the recording of this presentation will be available on YouTube following the meeting for the district's account. If no one else has anything to add, I can move on to the next question. Okay. One of the questions that we received from Mr. Roth, isn't the upstream drainage area concentrated in 3 massive pump stations? Those flows are huge. So just some clarification there.
Yeah, this is Jennifer Leeds again from the district, so I'll answer that one. So Mr. Roth is referring to the 3 pump stations that are associated with the Picayune Strand Restoration Project. And again, with that project, one of the primary purposes is hydrologic restoration, so restoring the sheet flow in the area. But we're not just looking for the flows coming from Picayune Strand. It's also, like I was talking about a little bit earlier, some of the flows that are heading south from Belle Meade and some of the agricultural areas and the urban areas. And yeah, those pump stations are very large, but they are large to be able to promote the sheet flow that is necessary to restore the Picayune Strand restoration area. Thank you for putting up the map. And so those are a portion of it. And then again, if you look on that map, you can see an area that says Belle Meade, and then you have the area in white, which is some more of the ag and urban development.
Jennifer, Leeds, I think this is really a good, because there's a lot of questions that kind of center on this a little bit. So I think it's very easy to look at all of the myriad of projects that are going on. We talk about the larger pump stations that are restoring the sheet flow in the Picayune Strand. But what we're really dealing with in this study area is that we have an existing condition where we have got known flows coming through known locations that have water quality issues associated with them. When we look at what's going on with the Picayune Strand and future flows, we're going to see in all likelihood, due to increased sheet flow in this direction instead of the old point source channelized version, we're actually looking at potential for increased flows in the area. And I think those two things combined are why it's important to at least take incremental action now, and begin looking at what we can do in the future. And I think that the idea that if we just sit and wait and see what happens down the road, we're going to be losing the opportunity to make some of those incremental improvements and make some changes that help us in the shorter term versus the longer term. And so again, I just ask you, if I've characterized things there in a way that you feel needs correction, please do. But it is they all are having a degree of interplay as we go forward. And we're just trying to find that, pardon the phrase, but kind of the low-hanging fruit of how we can make some incremental steps sooner rather than later.
Yeah, this is Jennifer. Tim, no, I think you really hit it right on the head and spot on. Again, kind of going back to the question when someone asked, do you want to use like the impaired waters rule and TMDL, and that those are all really good tools to be able to use, but they also take a lot of time. And so I think Tim hit it on when talking about this incremental approach. And so as some of these projects and some of these things come online, we want to be more proactive and work with everyone to see what can we do to add things incrementally and see the improvements in the downstream areas. And as we go through time, see how some of those improvements happen. If there's need to come back through some type of adaptive management, look at that as well. But yeah, spot on with that. So thank you.
Thank you. Now, we've had a question regarding funding. Is all of the funding for these projects coming from the government? Have there been any discussions for allowing an in lieu fee mitigation program to create these treatment options, or could either state or private mitigation banks be allowed to restore areas and sell credits?
Well, this is, as we were discussing a little bit earlier, part of our feasibility study is really looking at, what the potential temp or interim solutions may be and what the cost of each are. And then the district and the basin and others are going to work very closely with all of their partners to identify funding for that. As it stands right now, because we really don't have a project clearly defined, it's difficult to answer any funding questions, but I'll defer to someone in the district if they would like to address funding a little bit further on this. But at this point, it's going to be a collaborative effort. It probably will involve one or more agencies to get anything done. And I think those agencies are committed to working together to make that happen.
So this is Jennifer Reynolds. I would love to have the conversation about opportunities for mitigation and mitigation credits. I think that is an area that is woefully underutilized right now in South and Southwest Florida, really all of Florida. I think that there are ample opportunities to look at how mitigation for our developing state can work more hand in hand with restoring, preserving, and conserving our water resources. So I would love to have that conversation. Please don't hesitate to contact me.
Thank you. From Mr. Crane, has more water been diverted south in the last 10 years in an effort to reduce flow in the Golden Gate Canal?
I think that's probably something that would be best answered more or less by the district, but I do know there hasn't been, to my knowledge, any significant diversion projects, but there is one that may, if it comes to fruition, and I think the funding source may have been tied back to money that went out to coastal counties from the BP oil spill, that could potentially divert and treat water from the Golden Gate Canal. But as far as I know, there's not been anything in the last 10 years that has provided a significant diversion of flow. But again, I'll defer to the district to correct me on that position if I've not stated it properly. And I'm not going to give anyone more time to correct me. Let's just assume I'm right, and we'll go forward to the next question.
Sorry, I was just going to say that, for the district, let us, it's a good question, and I don't know the answer to that. So I'd like to come back and answer that for you. So we'll check into that.
And maybe we can flag that as a question that we can include in our public meeting update in December.
Perfect.
Now, another question that's come in from Mr. and Mrs. McAlone. We said that we were focusing something that can be done quickly, but all of these ideas presented today sound like they will take a lot of time and planning. How quick is quick? And when would these technologies be put into effect or get underway?
And Jennifer Reynolds, you mentioned in your comments at the beginning of the presentation that ideally we're looking at a 2 to 3 year window. Is that still kind of the goal, to have something implemented and operational?
Yeah, I think we'd like to see something trying to move forward. It may need to be incremental, but having something that can start to work hand in hand with the Picayune Strand project as it comes online. And so that that project, components of it complete in 2023, and then the final canal plugging is scheduled to complete in 2024. So that's the timeline that I'd like to have a solution in place.
And that sounds like a long ways off, but for those of us that have been watching that project develop over literally decades, hearing that that the end is in sight is really good news.
Another question we received, is the 72 million gallons the non-storm runoff flow rate?
Amanda, do you want to try and tackle that one?
Sure. It's actually based upon monthly flow that's broken out for on a daily basis. So my assumption is yes, it does include storm flow, but it's been normalized basis.
And so that number really is a discharge rate at that point, correct?
Correct.
The only other question that we have at this time, if the farmers are compliant, where else are the nutrients coming from? There's minimal impervious surface in the watershed.
Yeah, so I'll take this. So I think this is a good question. So I think this is, I think we touched upon it a little bit earlier, and part of the study, we're going to have a, not just alternatives for projects, but we also want to have like a recommendation section. And so if we feel that we don't have enough information to, determine either exactly where things are coming from, or if we feel we need to put some more monitoring in to kind of help us tell the story on where, like with the new flows coming under US 41 or potentially upstream areas, then one of the recommendations that come out of this could be for some additional monitoring to kind of help determine and answer some of those questions.
Thank you. We also received a request that if we could also include flows diverted that used to go south farther east near Port of the Isles, that would be appreciated as well. I don't know if that would be included in our area of study, but that was a request that came through from Mr. Crane.
Well, we'll certainly discuss that with the district, but I think maybe some of kind of when we focused in on the study area and we showed directional flow arrows and whatnot, there may be kind of a post Picayune restoration project flow map that would help kind of orient people to that on a little broader scale, if that can be developed. But we certainly appreciate the comment, and if it's possible to do so in the time frame and the scope that we have, we would be happy to share that.
Thank you. At this time, we don't have any other questions. Are there any other questions that the audience today would like to submit before we close? We'll just give it a few moments.
And while folks may or may not be furiously typing those last couple of sentences, again, just want to emphasize the week of December 7th is when we are targeting the next public meeting. I do expect to have, hopefully we're going to have a little more of a detailed land-based report to share with you as a result of the feasibility analysis. So I think a lot of the questions about, how it looks or where it may be located or how much land is required and what will it treat, that is really going to be addressed in the next phase to a greater degree. And we certainly appreciate all of the input and comments that we received today.
Thank you. And no other questions have come in at this time. I would like to mention to those who are attending the meeting today, you can sign up for project notifications if you visit our sign up for updates constant contact landing page. All we really need is your email address, but if you can include your name and other contact information, that will help us keep track of who is participating in our meetings. Thank you so much for your input and participation today. And if those of you aren't able to access the link, we can email it out following this meeting to those who were able to attend today who registered via email.
So just to confirm, Yvonne, everyone who registered and provided an email address, you'll go ahead and provide that link to them?
Yes, so that they can sign up for updates.
Great,
And
thank you.
Yvonne, this is Kyle. If you would please also include the link to the website on the district page, just so people can find it easy. I'd
Oh,
appreciate it.
absolutely.
Thank you.
Well, if nothing further, shall we go ahead and bring this meeting to a close today and just thank everybody for their time? Great. Thank you again, everyone. Have a terrific day, and we look forward to having continued conversations with each of you.
Thank you.